Hey there, welcome back to lesson 6. We're talking about modeling non-periodic context. In this video specifically talk about modeling a quadratic function in context with data. Again, what we're doing here is we are going to create an equation, multiple equations, called a system of equations, and we're going to solve it one way or another. Tools in your tool belt should be solving via substitution, elimination. If you have graphing technology, you can use graphing, and then I'll also touch on the regression component that you can use if you have access to Desmos or a graphing calculator. So I'm going to go ahead and jump back into an example, and let's see where this one takes us. Example: the table gives the number of people shopping at a certain farmer's market H hours after opening for business at 7 a.m. H equals 0. The number of people shopping at the farmer's market can be modeled by the function P of H equals A times H squared plus BH plus C, where H is the hours after the farmer's market opens. And they give us this data in the table. They say here for question A, again, this is modeled in FRQ number 2, use the data to write 3 questions that can be used to find the values A, B, and C. So I'm going to go ahead and I'm going to take, again, they say this data is modeled by P of H, right? So P of H is A times H squared plus B times H plus C. And I'm just going to replace this information from the stuff in the table. And usually they do tell you this in the table, that this is P of H and here's H. So I'm going to replace this. So 4 is equal to A times 1 squared plus B times 1 plus C. And I have 18 is equal to A times 3 squared plus B times 3 plus C. And 48 is equal to A times 5 squared plus B times 5 plus C. So there's my equations. I just replaced the number of people and the H value, I plugged that in, okay? So how the heck am I going to solve this? Well, usually what happens, especially when you have this data, is one of the equations will give you a variable, and that is, well, kind of true here. So for the first one, right, they say, okay, 4 is equal to A plus B plus C. And then I have my second equation. We have 18 is equal to 9A plus 3B plus C. Okay, and I have another equation. I have 48 is equal to 25A plus 5B plus C. And so I went ahead and I separated it this way because I'm going to show you that here I have 3 equations in a system. How do I do it? I'm going to solve the equation involving only 2 of the systems at a time, and I'm going to use the resulting equations to break down another system. So let me show you. I'm going to take these 2, and I'm going to solve via elimination. I'm going to subtract. And so what happens is my C values cancel, and if I was smarter about this, it would be reversed, where I wouldn't have a whole bunch of negatives, but it's fine here. Negative 14 equals negative 8A minus 2B. Okay, so there's one equation, and then I'm going to go over here back to this equation, and I'm also going to write down my second equation again. So my third equation and my second equation. So first I use the first and second. Now I'm going to use the third and then the second again. So 9A plus 3B plus C, and I'm going to do the same thing. I am going to go ahead and subtract. I'm going to eliminate C. And so what I get here is I get 30 is equal to 16A plus 2B. Okay, check this out. Now I have a new system of equations. So I'll go ahead and let me do this. Let me just rewrite them down here. 30 is equal to 16A plus 2B. And actually now the negatives are going to kind of work in my advantage. 8A minus 2B. Okay, and what I hope you notice in this system is now I have opposite B values. So I've been subtracting all this time when doing elimination, but you can also add. I can go ahead and I can add these, and when I add, again, now these B's cancel. 16 plus a negative 8A is a positive 8A, and 30 plus negative 14 gives me 16. Look at that, I have one variable. So I eliminated it twice. Okay, you have to use two sets of different equations, right? One and second, and then the second and the third, or you could have, mixed and matched another way. Just don't use the same two, and then you use those resulting equations to eliminate. And that now I have one variable. So now we know that a is equal to 2, right? Divide both sides by 8. Okay. All right. What do I do with that? Well, I'm going to take this 2 and I'm going to plug it into one of these equations. I know that 30 is equal to 16a plus 2b plus 2b. Well, I'm going to plug in 2 here. Okay, so I get 30 is equal to 16 times 2, which is 32. Okay, and then I'm going to subtract 32 on each side. Subtract 32. This cancels, and I get negative 2 equals 2b. 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 There we go. And we'll go ahead and divide by 2, and we get b is equal to negative 1. Whew! Oh man. Okay, so I've solved for a and I've solved for b. Now the only one I'm missing is c. I'm only missing c. And what I'm going to do is I'm going to pick the nicest equation out of them all. Usually that first one, 4 equals a plus b plus c. Okay, so let's take that equation. 4 equals a plus b plus c. And I'm going to plug it in. So I know that a was what? 2. We know that b is negative 1. And we don't know what c is. But this equals 4. So 4 is equal to 1 plus c. We'll go ahead and subtract 1 on each side. And we get c is equal to 3. There you go. We found all of those values. Oh my gosh. That was a lot of algebra, right? 3 equations. You just have to do systems of equations twice with 2 separate equations, right? So you can mix and match any which way. Solve those resulting equations to find one variable. Once you have one, use that same system to find the second one. And then I take those 2 variables and I plug it back into an original system that has all 3 variables to find this. Now that was fun, but there's got to be an easier way, right? Right? There is. If you have graphing technology, we can go ahead and add a table. So this is Desmos. I'm going to add, it's free, you can go online to it. I'm going to add a table and I'm going to enter my data. So 1, 3, 5 were my inputs. My outputs were 4, 18, and 48. And you'll notice this little button pop up over here on this side. It says add regression. Ooh, what does that mean? Well, what a regression is, if I click this, is a modeling technique that will fit a function to the data that you entered. And so you'll notice here that when I made this table, it actually plotted. It actually plotted those data points. You can see them as purple dots there. And so, oh, there we go. So there's the 3. And so what it's doing is it's fitting a linear function to this. Now, we said that this is modeled by a quadratic function. So if you click this drop down, you'll notice there's all these different regressions. Yes, we'll talk about all of them this year. And I click quadratic regression, and hey, it is fitting that function, right? Quadratic function to that data. And what you'll notice is right here, y equals 2x squared minus x plus 3. Do those numbers look familiar? Well, isn't that your a? A is 2, b is negative 1, c is 3. Hey, it gave it for me. It gave it for me. And if you wanted to use this, you could click this button and it'll drop it down here. And you can do lots of things, right? Like I can call this the number of people based upon X. It's called P now. So if I want the number of people at this farmer's market, I don't know, in 4 hours, I can enter 4 and it'll tell me 31 based upon this regression or this model. Okay? And again, it's just a prediction. So that is one way, if you have access to graphing technology, that you can solve these equations. Pretty cool, right? Okay, let's go ahead. Let's look at some practice ones. Here are some practice ones. Please pause me. I do recommend that you try this without the graphing technology at least once, and then you can verify with graphing technology. Graphing technology is so easy, but do work on your algebra skills. Okay, so pause me. Let's look at this one. Hey there, I just wanted to check in with you. Here's what your three equations should have looked like by plugging in the given data into the function v of t, where we're talking about the number of views of a social media post after a certain amount of hours. And so here's your system. So you get the point, you just have to plug in again your output and your input. And then in order to solve, you have to create first two systems of equations. And so I use the third equation and the second one here. And then I use the second and then the first one here. And I eliminated. That's what I did second. I eliminated. So the c variable canceled. And then I have these two equations, which my third step, I create a system from those resulting equations. Okay? So go ahead, pause me, keep going. Whew, this one was a lot. Let's go ahead and check. So if you got to this resulting system and you wanted to go ahead and eliminate, we kind of ran into a brick wall because I don't have opposite coefficients like I've been used to having. So you really have two ways you can go. You can solve via substitution, and if you did that and you got the same answers I got, good job. But I did not do that. I went ahead and I still eliminated, but what I did was I used a scalar multiple this equation. I multiplied both sides by 6, and you could multiply by -6 if you wanted to add, but I multiplied by 6 so that I got an equation where my b's had the same exact coefficient. Okay, and this is a 6. This should be a 6b. Okay, and so I subtracted, and I get 42 equals 42a, right? My b's cancel, and so a is equal to 1. Hey, I have a. What do? Well, I'm going to take an equation for b, right? One of my initial resulting equations, and I plug in 1 for a because I just found that, and then I solve for b and we get b is equal to 4. All right, got a and b, I got b. So then I go back to one of my original equations, the simple one, 4 equals a plus b plus c. Substitute a and b, and I get c is equal to -1. Pretty straightforward in doing that. Again, you can also go ahead and create a regression. Let's check out what Desmos has for us. Okay, and here's what your table in Desmos should have looked like. And if you hit quadratic regression, again, here's your a value, your b value, and your c value, right? And this matches exactly what they gave us in this model for the number of views of this post, right? V of t equals at squared plus bt plus c. So that equation models it. There's your a, b, and c. Desmos, super, super fast, okay? All right, I thought I had one more. I do have one more. Here is one more example. Please go ahead, pause me, try this example. Oh man, that was a fun one. Again, if you mess up at any point along, just pause me so you stop hearing me talking. You can fix your error and then correct your errors from there. But your equations, again, we can enter this information. I like this example because they gave us a t equals 0 value, which is an initial value. I love inputs of 0 because they erase lots of coefficients. And so you'll notice here that with our input of 0, we end up getting 20 equals 0 plus 0 plus c. What does that mean? It means that c is equal to 20. Now that I have that, I can replace it in my other two equations. I know that 44 is equal to 9a plus 3b plus c. Well, c is 20. 4 equals 64a plus 8b plus 20. So now I have a system here that I can go ahead and solve. Now, before you solve it, before you try to subtract, a couple of things have to happen. One, notice I got to get rid of those 20s. I got to move those over so I just have the variables in there. And then when I did that, I still noticed that, hey, I can't eliminate. I don't have opposite coefficients. And if I was to try to multiply one of these equations, turning a 3 into an 8 or a 9 into 64 is going to require a fraction multiplier, which just does not sound fun. So what I did was I just took this top equation and I solved for b. I said, hey, what's b? And I went the substitution route. So this method of solving is substitution. Okay, and so I moved the 9a over and then I divided by 3, and so I got b is equal to 8 minus 3a. Remember, when you're dividing two terms by a monomial, you have to divide each term by that monomial. You can't just cancel one of the terms. It's 24 over 3 and it's 9a over 3. So 8 minus 3a, that's b. Once you have b in this term, I could go ahead and I plugged it into my second equation. So I took the negative 16, right? I took this equation here. The negative 16 equals 64a plus 8b, and I replace b. And in doing that, I end up getting the equation after I combine my a's. I get 40a. And then I subtract the 64, I get negative 80. And then I divide by 40 to get negative 2. So a is negative 2. And we're almost home free. Now that I have a, I plug that back into that equation for b, and we find that b is equal to 14. So here's your conclusion that you should have came out of this with. And again, Desmos, super easy. If I have a table, I can input the table. I run a quadratic regression and check it out. There is my equation. Okay, so hopefully in this video you learned how to model a context involving a quadratic function or given data points that can be modeled by a quadratic function, and how to solve for that via substitution, elimination, and with a regression using graphing technology. Give the video a thumbs up if you learned something. I'll catch you in the next video.